Only because I see that this is called the dividend and this is called the divisor. The dividend only has two terms. So before I start, I really should rewrite this dividend. This is after page 202, polynomial division. We did all of the first part yesterday. When you're setting up your dividend, it's kind of helpful to have every term represented, including ones that are missing. So a squared plus 0a minus 28 is going to be a helpful way to write that problem. So now I put my a minus 5 on the outside of this box. I'm going to do division using this box. So my dividend times my quotient is going to go up here, is going to equal the dividend, right? And I compared it to an example of like, if you take 56 and divide by 7, you get 8 as a solution. Let's go backwards. 8 times 7 will get me back to the 56 that I started with. So this circle times a minus 5 is going to give me my dividend inside these boxes. So a squared is the first term of my dividend. That goes in the top left of my box. Now I know the first term of my quotient. Because what times a do I need to get a squared? A. So the first term of my quotient up here is a, because a times a is a squared. Now, what's the next step that I can do? A times negative 5, right, to get this box. So I have negative 5a. So now, this diagonal right here has to add up to the 0a in my original dividend. I'm currently at negative 5a. What do I have to add? 5a. Now that red circle is equal to the red circle from my dividend. So that adds up to the same thing. What's the next term that I put up here in my quotient? What times a will give me 5a? So I put plus 5. That's my quotient. My quotient is now finished. I can do my remainder now. 5 times a is 5a. 5 times negative 5. So I put a negative 25 here. Now this diagonal needs to add up to this negative 28. I'm currently at negative 25. So I need to subtract an additional negative 3. That's called your remainder. So negative 3 is your remainder. Your quotient is a plus 5. You want to do one more together and then try 2 on your own? You think you need one more, or do you think you can do the other 3? Question? Because see how in the original problem there's nothing written for a? Look at the problem below it. See how I have 5x in this problem? There's 0 of them. So I was just representing it with a 0 so that when I get to this step, oh, these have to add up to 0. So there's no, like all the other ones have it. See how this has n squared, then 3n? That was the only one that didn't have it. That's why I decided to do that one with you. You guys think you can try the other 3? All right, you try the other 3. I can come around and check them. I'll just make an answer key of them first. N squared, negative 7n. Negative 28. Negative times my remainder. X plus 6 y-intercept of any function, even if this is 204, you should be able to find the y-intercept of any function, even if you've never seen it before. Because how do I find the y-intercept of any over, I don't know, or non-polynomial. How about that? So if I plug in 0, I get the y-intercept. So in this function, I plug in 0 for all the x's, and all that's left is 1. So like 0, 1 would be the y-intercept. On this next function, I actually have to plug in 0 and figure it out. So it'd be like negative 3 squared is 9, plus 1 is 10. So 0, 10. What about for this function? The square root of 0 is 0, plus 1 is 1. What about this function? Does anyone know what 2 to the 0 power is? Anything to the 0 power? It's actually 1. It's a tough rule to remember. But 2 to the 0 power is 1, and 1 plus 3 is 4. So you can remember plugging in 0. That's all we're doing in this new kind of rational function. So it says, anytime you find, these are all examples of finding y-intercepts. That over there was just, that's a strategy that we're using in algebra, in pre-calculus. Over here, now these are all rational functions. What's the definition of a rational function? I wrote it up here a second time for you. It's just the ratio of two polynomial functions. Polynomial divided by polynomial. So let's do the first one together. If I plug in 0, I would get 2 in the numerator, and I would get negative 9 in the denominator. So 0, negative 2/9 is the y-intercept, right? So just plug in 0 for x and see what you get. What happens in g of x? I get 0 in the numerator. This is page 204. You see where I am? Page 204. I get negative 9 in the denominator. What is 0 divided by negative 9? 0. And a lot of students get confused with dividing with a 0. So if you are ever uncertain, take 0 and divide it by the number in your calculator. Your calculator will tell you that the answer is 0. So for full credit, when you're finding a y-intercept, you need to actually simplify the fraction and tell me the final answer. So don't leave it as like 6 over 2 or 0 over negative 9. All right, see if you can do h. Try h by yourself. J is a little bit different, so wait when you get to j. So all I have left is a 5 in the numerator and a negative 8 in the denominator. So 0, negative 5/8, or you could leave it as 5 over negative 8. It means the same thing. 5 over negative 8, negative 5 over 8 means the same thing. What's the problem on J? Something kind of funky happens. 1 over 0, is that allowed? Can you divide by 0? It is undefined, and if I try it on the calculator because I've forgotten, it says error, you can't divide by 0. So there is no y-intercept because you cannot plug in 0. So these are the 3 different types of answers you might see. You might get 0, 0, 0, a different number, or no y-intercept. So to me, that rule by itself is not hard. Plug in 0 for x. What makes rational functions get a little bit harder is now there's going to be multiple rules that you kind of need to think about. Okay, I know how to find the y-intercept. If that's the only question I ask you, you could get it right every time. But now I'm also going to show you how to find an x-intercept. So I think it's when students have both x and y-intercepts to figure out, they get confused. And if you figure out which axis you're on, if I'm on the y-axis, x is always 0, right? If I'm on the x-axis, what happens? y is always 0. So on the next page, instead of plugging in 0 for x, we're going to plug in 0 for y. And there's a shortcut that I'm going to show you. This is really y equals, right? Y equals 0 equals 2 plus x over x minus 9. What's your first step when you're solving a fraction? You are going to multiply the denominator to the other side of the problem. So I just multiplied the denominator to the other side of the problem. What's 0 times anything? 0. So no matter what your denominator is, after the first step, all you're going to have left is 0 equal to your numerator. So you can skip that step if you can remember that. Set your numerator equal to 0 and look for your x-intercepts. So what would make this equation true if x is what number? -2. So x equals -2, so -2, 0 is my x-intercept. And if you look up in the directions, in the case of rational functions, we just set the numerator equal to 0 and solve, because we're plugging in 0 for y and multiplying that to the other side. So all you have to do on the rest of the problems is set the numerator equal to 0, and here's where you need to be able to factor on letter H. So you've got 3 equations to figure out. See if you can solve for x in each of those equations. I think the bell's going to ring in 2 minutes, so you have time to try at least, well, g is done, right? X is 0, so 0, 0 must be my intercept. See if you can factor h, right? You got to factor h. You got to know how to factor. How do you solve a quadratic? By using factoring. So here's where you need factoring. Yeah, the answer to J is that there is no x-intercept, right? Because 1 can never equal 0. So the only one that you still need to solve is factor using the diamond method and figure out what your x-intercepts are. Yes, there's going to be more than one answer to that H. There's going to be 2 x-intercepts because you have 2 separate factors. So, thank you. Welcome. Yep.